Hey guys, in today's video I'm going to show you how I built this 5 kilowatt hour portable power station using these two batteries from BigBattery.com along with this 2.4 kilowatt inverter from MPPSolar. Now several months ago I had published a video on building a solar generator. It was a 3.5 kilowatt hour battery in a Craftsman toolbox. Several interesting comments and ideas came out of that video. Two of which were, why didn't I use a toolbox with wheels? And a few people also had said that it wasn't very DIY friendly because I used some tools and things that most people wouldn't have around the house. So that got me thinking about what I could do a little bit differently. And if I'm going to use wheels on a toolbox, I'm going to build something bigger because now I have wheels to support the extra weight. So I built this portable power station on an 800-pound capacity hand truck. And for the most part, this is a very quick build that pretty much anybody can do with around the house tools. So here we go, and let me know what you think. Alright, so first we're going to go over the three main components of this build. I have this hand truck I picked up at Lowe's. It's Milwaukee brand. It's rated for 800 pounds or 362 kilograms. It's got the D-style handle in the back and then two main bars that come down the front for support. And also has 10-inch rubber pneumatic tires on the bottom. I picked this model specifically for these tires as some of the cheaper models have little plastic tires and they're more difficult to pull through the grass. These rubber tires will be great for pulling through the grass outside as well as up and down steps in and out of the house. For the batteries, I have these two 24-volt, 100 amp hour lithium batteries from BigBattery.com. And these are fantastic batteries. These are made from Tesla Model 3 cells, new cells. They have a max continuous discharge of 100 amps and a max peak discharge of 200 amps for 3 seconds. Each one of these boxes is 2.5 kilowatt hours of power, so together we'll have a 5 kilowatt hour battery. And for the inverter, I'll be using this MPPSolar. It's a PIP2424LV-MSD. It's got a 2.4 kilowatt inverter and comes with a built-in MPPT charge controller, so it's an all-in-one device. So in order to mount all of the hardware, I have a piece of 1/2-inch plywood I'm going to install like so. And it is 4 feet high, and I think it was roughly 17 inches wide. I also have another piece of 1/2-inch plywood with some smaller boards on the side, and this is going to be used as the battery tray to support the batteries at the bottom. Now I debated for quite a while how I wanted to hold this battery tray onto the bottom of this hand truck because obviously I don't want it sliding forward when I'm moving it around. Now originally I was thinking I could drill through this with 2 locations, but you can't put bolts on the bottom of this plate here because this needs to be flat on the ground in order for these wheels to be disengaged. If this is lifted up even a little bit from having a nut or bolt under there, these wheels are going to catch and I want to make sure it's not going to like roll away or something like that. So I'm going to use these rather small L brackets to secure it to the plywood that's going to be vertically. So I want to place the tray and I want to make sure it's centered. And here we are with both of the L brackets in place. Again, they are kind of small, but remember these brackets are not supporting the weight of the batteries. The weight of the batteries is being supported by the hand truck itself. This is just to prevent them from sliding out, when you're pushing it around or whatever. So next we need to secure this plywood to the frame of the hand cart itself. And the best way I found to do that is just to take these standard 3/4 inch EMT conduit straps and they will fit around the hand cart perfectly. So we'll put a couple on each side here, but for the first one, and screw it down. Now this is thin plywood, this is only 1/2 inch, so you don't want to tighten these down too much. And you also can't use a bigger screw or it's going to protrude through the other side. Alright, so I got 2 straps on the top. And then I got 4, about 1/3 of the way up from the bottom. So that is plenty of strength to hold this plywood to the cart. Alright, so now I can lay the hand truck down. And we'll position the inverter near the top. Again, I'm going to make sure it's centered on both sides here. Now it appears these 2 screws at the top are the only screws for securing this inverter down. So I did add 2 screws underneath the inverter as well. Just making sure the head of the screw caught the bottom of the enclosure just to keep it from flopping around as I'm moving it. Alright, so now with that done, we're ready to put the batteries in. Now these batteries connect using an Anderson 175 amp connector on the left side of the enclosure. So there's one over here as well. So unfortunately we cannot put them next to each other like this, as there's no room to connect the connector in between, and there would have to be a several inch gap in between like so. So I did reach out to Big Battery and asked about different ways you can mount these, and they said you can mount it in any orientation as long as it's not upside down. So I'm going to plan to set mine on the side There's one. And there's two. It's perfect. So let's just test how that works out before we go any further. It's definitely a lot of weight, and you can definitely feel it, but you know, at 800 pounds for this hand truck weight capacity, that should have no problem picking it up and moving it around. The movement is very smooth, very easy to move. All right, so looking at the connections on our inverter here, battery positive and negative come out of these two green terminals in the center here, and the screws for attaching those are up in here. So I want to connect a 175 amp Anderson plug to the bottom of that inverter to use as the battery input. Now unfortunately this does require some sort of crimp tool. However, if you don't have a crimp tool, that's not a problem. You can actually buy these pre-made with wires already in them. So for the wiring from the main Anderson to the inverter, I just have a pair of 4-gauge welding battery cable. Let's start by stripping a little of the insulation off. Okay. Alright, so I crimped it twice. I really do need to get a better crimping tool. This connector was rated for 4-gauge wire, but I did have to crimp it quite a bit, but there's nothing technically wrong with it. Now we take our Anderson connector and we see the plus side, and if you look on the inside, you'll notice there are two metal tabs in there, one on each side. So this little notch here is going to grab onto those tabs and hold this connector from coming back out. So we'll hold the Anderson connector face side up, and one side says plus, and we'll just insert the terminal to the back, and you'll hear it click once it's in there far enough. There we go. So now you can see the first tab in there. So we'll do the negative lead the exact same way. Alright, so I kind of want to mount this connector over here on the right hand side, probably cut the wire about here, which is about a foot from the bottom of the Anderson up to the top. Now under some conditions you'll want to use a ferrule over these wires just to hold the strands together. And that really depends largely into what device you're putting these wires into. The clamps on these are square shaped and they have grips on both sides. So a ferrule, in my opinion, is not needed for this particular use case. However, you should evaluate each use case on an as needed basis. So making sure carefully not to mix up the positive and negative leads. And just tighten it down. Alright, so now I can take this connector up to the side and fix it like so with 2 Phillips screws, making sure you're not bending your wires too much. Okay, so that will be the main battery input for the inverter. Alright, so as I mentioned before, these batteries are each 24 volt 100 amp hours. Now my inverter is also a 24 volt inverter. So in order to use both of these batteries, we'll need to connect them in parallel, which will give us a 24 volt 200 amp hour battery bank. In order to do that, BigBattery sells this parallel cable specifically for these batteries. You can see there are 2 175 amp Andersons, which will go to each battery, and then there is another Anderson which they both combine into. This will be plugged into our main input that we just mounted. And this is actually a fairly lengthy cable. I think it's about 6 feet or so. It's very long. Now, one important thing to note before you connect any 2 batteries in parallel is you'll always want to check and make sure the state of charge is the same on both devices. So if I turn this battery on, I have 22.9 volts, and if I turn this battery on, I have 27.3 volts. So these 2 batteries are not at the same state of charge. One is near empty and one is near full. So if I connect this parallel cable right now to both of these batteries, I'm going to see a huge rush of power from one to the other, and I want to make sure I do not overload this circuit breaker, overload the BMS, or overload this wiring. I'm only going to use the battery on the right to start with until this one is drained down to near the capacity of this one, and then I'll turn both of them on and operate both of them together. This is very important. You don't want to mess up, with that big inrush of current from one to the other if you're at different states of charge. Alright, so with both batteries turned off, I'm going to plug in the combined input. Now these are big connectors and they take a lot of force to connect. So there we go. That wasn't too bad. And now down at the battery, ready to connect both of those as well. Again, you really got to push these in to lock them into place. So, as you can see, we have a lot of extra cabling we'll have to clean up and tie down nicely. Now, with these batteries connected and tied down nicely, we're ready to talk about the AC output of this inverter to turn these batteries into AC power that we can use to power our appliances. So to do that, I picked up these commercial grade 20 amp outlets, and we can tell these are 20 amp rated outlets because the larger neutral prong has a T shape as opposed to 2 vertical prongs. Now with this inverter being rated for 2,400 watts, which gives us 20 amps at 120 volts, I didn't want to use standard 15 amp outlets because I don't have any sort of overcurrent protection. So by using 20 amp outlets, I don't risk the outlets themselves because I can safely pull all 20 amps through one receptacle. And I'm going to mount 4 of those outlets in this 4-gang outlet box, which will give me a total of 8 receptacles I can mount on that inverter. Alright, so now we're able to begin talking about how we're going to wire up these outlets. So I have a standard piece of 12-2 wire here. And what that means is you have 2 conductors, they are 12 gauge each, and then you also have the ground. So this is 12-2 Romex. And 12-2 Romex is good for up to 20 amps. On the left side of this enclosure, I have a standard cable clamp, and I'm just going to pull the wire through, and I'm aiming for a 1/4 inch of insulation to be sticking through the clamp, and tighten it down. Now before we go any further too, we need to talk about safety. And that is such that AC voltage can be very dangerous and even fatal if you make a mistake. If you're not competent or qualified to do this type of work, please contact somebody who is. I don't want to see anybody getting hurt because of this project. So that disclaimer is out there, be careful. So now I have here 3 of the outlets we're going to be using for this box, 3 of the 4 anyway. And you can see I connected them on the back using the same 12 gauge wire. The black wire will always connect to the smaller blade of the socket, or the brass colored terminal. The white wire will always connect to the larger blade of the socket, or the silver colored terminal. So as you can see, I have these outlets wired in parallel. The whites are all connected together, and the blacks are all connected together. So the first step on this box itself is I need to connect this ground wire to ground the enclosure itself, and that's what this screw hole is for down here. So I just have a standard ground screw, and we're just going to wrap that conductor around the screw, and obviously tighten it down. And I'm just using a standard pair of wire strippers. You can pick these up at pretty much any hardware store, and it makes stripping these off very easy. And then one thing I love about these commercial grade outlets are the terminals on the back. So I know it's a little hard to see, but you insert your wire into these slots and then tighten this down, pulls this metal piece in and clamps on your wire. It's not like standard cheap outlets where you got to wrap the wire around the screw and then hope it doesn't back out when you're tightening it down, all that stuff. So starting with the smaller terminal first, just going to insert the wire into the back. And then I also need to insert the wire from my parallel string as well. I can put 2 wires per terminal on these, which is perfectly fine. And once you're sure the wires are seated nicely, you can tighten them down. And on the other side, I connected the white or neutral wire the same way. Now I just need to go through and wrap these grounds around all of the ground screws. Alright, so once that's done, you'll want to go through and double check all of your wiring, double check the tightness of all the bolts. We are ready to screw down the outlets. Folding all the wiring into the enclosure, start with the rightmost outlet here. Alright, so with that done and all of the outlets mounted, we do need to get this box mounted to the board, and it probably would have been a better idea to do that before we put the outlets in, but I can see the screws down there, so I don't think that's going to be a very difficult thing to do. Alright, so once the box is mounted, you're ready to put the cover plate on, and there's a few common screws that hold that down in the front. Being extra careful not to slip the screwdriver off so you don't scratch your nice stainless steel cover. Alright, so with the outlet box mounted, we're ready to make the AC connection. So under the inverter, you'll notice there is an AC in and an AC out option. The L is the line, which is the black wire, and the N is the white, which is neutral. And for the AC input, I'm just planning to use a standard extension cord. I picked up this heavy-duty extension cord on Amazon. This is 12 gauge wiring. Many of the cords you'll find in hardware stores are like 14 or 16 gauge. As I'll be running anywhere from 12 to 50 amps through this cord, I want to make sure it's heavy-duty enough to not cause a voltage drop or heat up too much. So I just took the cord and I got about half of it here, and I'm just going to cut it in half. Now this is kind of painful to do because this is a very nice cord, but I only need the male end of the plug. So cut it. And we'll remove a little piece of the yellow jacket. And we have 3 conductors as well under here. We have the green ground, the black hot or line, and the white neutral. And like before, we'll strip about a 1/2 inch of insulation off. And that is very nice wire. This is why it's worthwhile investing in a heavy-duty extension cord, not the cheap stuff you'll find at your hardware stores. And so the extension cord is going to get connected to the AC in, the line, and the neutral position as well. And I'm just using a 1/2 inch EMT clamp to hold these wires down nicely. Now to hold this wire in place here when it's not needed for charging, I just took a 1.5-inch PVC conduit clamp as well, and I just cut it in half. And now I've got a hook to store the cable. It's a very clean, nice look there as well. And now we can put the original cover back on the front, and that just had a screw on each side. Now I did plug both of these batteries into a charger last night, so they are balanced at this point. We can go ahead and turn both of them on. So we see we have 26.8 volts, and we're seeing display over here, even though this breaker is not turned on yet because these are wired in parallel. However, you see me turn this one on as well, and we're still at 26.8 volts. Alright, so with both of the batteries turned on and all the wiring completed, we're ready to turn the inverter on. And it'll take a few seconds to start up. You can hear some fans going. Plug in a light for testing, and there we go. It's working. And here you can see the display itself. There's an input of 0 volts because the power cord is not plugged in, and it's showing an output of 120 volts AC. Now to program this, you could use the buttons on the front here and go through the menus, but I find it's easier just to use the laptop and the software that came with the device. So on the bottom you'll notice a USB port there in the back. So we'll want to take note of a few of the parameters on the front of this battery. We have the charge specification is 29.4 volts at 30 amps. The lowest voltage acceptable is 21 volts. Now unfortunately the software here will not allow me to go above 29.2 volts, but that's perfectly fine. Now for the max charge current, we have to remember that we have two batteries in parallel. One battery is rated for 60 amps charge, so we can charge this at a maximum of 60 amps. However, we need to be careful not to overload our extension cord or the 15 amp outlet this will plug into. So we can probably bump this up to 50 amps. So if we have 50 amps times 29.2 volts, that's 1,460 watts. Divided by 120 volts is 12.16 amps. That's perfectly fine, so I'm going to go ahead and save that change. Additionally, we have the low cutoff over here. BigBattery specs these at 21 volts for the load disconnect. Alright, so I want to charge this up, and then we'll take it outside, and we'll see if it can start some power tools and some other heavier loads. Grab my extension cord. I'll just plug it in. And after a few minutes, we see it is now charging. The charging symbol is blinking, and the charging light is blinking as well. So if you press the down arrow on the display panel, it switches the AC input gauge. We can see it's charging at 22 amps currently, and it looks like it's sitting right around 50 to 51 amps, which is fantastic. So I'm seeing full charge at this point. Alright, so one of the ways I see people testing their inverters is using power tools. So I brought my hand truck cart out here to the woodshed. I have my Craftsman vac that I use for dust collecting, and I have my DeWalt miter saw that's rated for 15 amps, and I believe the rating on the Craftsman was 7 or 7.5. So we're going to see if it'll power both of these at once. So got the vacuum, and we got the miter saw. Alright, that started perfectly and it sounded wonderful. There was no hesitation. And looking at the display while I was doing that, this inverter maintained 120 volts. So it actually adjusted itself to ensure there was no voltage drop. So yeah, all in all, I think this came out very well. I'm very satisfied and proud of this build. These batteries and this inverter are the heart of this operation. These batteries come pre-built in these enclosures. They're in steel boxes, so they're safer than DIY batteries. They include all the overcurrent protection built in. They include a BMS. You don't have to worry about any of that wiring, no spot welding, nothing like that. These are pretty much drop-in, ready-to-go battery modules. These batteries coupled with this inverter that has a custom mode to support lithium battery settings is perfect. Additionally, having 8 receptacles like this eliminates the need to plug in power strips or adapters or anything like that. You got plenty of room to plug in your appliances, even if you've got those wall wart things that cover up the nearby receptacles. Now in this video, I didn't worry about plugging in the solar input. This does have an 80 amp built-in solar charge controller. So if you have an array like you see behind me here, and you want to have a lead coming off that array, or you just wheel up your cart and plug it in, and that would be a great source for clean and efficient power. Now that this project's completed, a few things that do come to mind. I really would have liked to have a GFCI rated outlet here in the left position. That way all of these receptacles would have had GFCI protection. However, it's very difficult to find a plate that has one GFCI cutout with 3 standard duplex receptacles. I suppose I could have used two 2-gang boxes, but I like the look of having all 4 in one box. Now, if you want more than 5 kilowatt hours of power, the great thing is this hand truck has plenty of weight support that you can actually put a second level of batteries up here. You'd have to move the inverter up a couple inches and then move this box up a little bit, but there is plenty of room to fit a second level of batteries here. Now, if I were to do that, I would probably put posts coming down the front, and then I would have to strap the batteries to the back of this just to add some extra safety. So when you're wheeling around, you don't want the batteries flopping forward or anything like that. Now, unlike my solar generator build, this portable power station does have a slightly higher price tag, because when you're buying these batteries pre-assembled like this, you're paying somebody else to do the work, to harvest them, to assemble them, to spot weld them, to put the BMS in and all that sort of stuff. So these are around $8.55 a piece with the discount code BATTERY. That will give you 10% off, and these are also free shipping as well. I'll link to where you can purchase all these parts in the description. If you found this video interesting, please don't forget to hit that like button. Any comments or suggestions, leave them in the comment section below. And thank you very much for watching.